Okay, Iris, thank you very much for the introduction. Hello, everyone. Good morning. Well, here's good afternoon. I'm just talking to you from Berlin. I'm really excited to talk about this topic now. If you have been following all the Qt for Python story, we already had two webinars, one mainly about the introduction to the project, and the other one was more like a hands-on on writing a data visualization tool. If you haven't, and if you are interested in it, you can maybe check out the resources.qt.io, and you can check the other webinars there. So as I mentioned before, we had this webinar already here in Europe. We got really interesting questions. So hopefully you also can write down your questions that we will have maybe the last 10 minutes or something. I will try to answer them all. If not, at the end of the presentation, I will share some information where you can find a team or you can directly message me. So don't worry about if your question get not answered during the webinar. So as Iris was saying, my name is Cristián. I am currently the team lead of 3 teams here in Berlin, the Qt for Python, QML, and Qt Core. I have been working in Qt for Python for 2 years now. So hopefully through this webinar, I can transmit you most of the things that I learned during this process. And but still, it's a topic that required maybe a couple of webinars, but I try to put everything here on this presentation. So as you can see here in the outline, I didn't want to bore you much about with a lot of introductions or many slides. So I promise those things will be maybe 20 slides much, but I wanted to focus more on the hands-on experience, which is at least for me the best way of learning new things. We will show 3 main examples of Shiboken, increasing the difficulty, of course, as you can see there. And with the last one, which is a really, really cool application that we have been showing in the World Summit of last year, for example, and it was really getting a lot of attention. Most of our customers and users are trying to use this application as a base to start new nice products. So let's go for it. So first of all, if you have not been following all the Python story in the Qt project, it's really an interesting area now. We are kind of opening Qt to a whole new set of developers. And if you have seen lately with all the AI or machine learning boom that many people is kind of jumping into programming, jumping into learning algorithms, and etc. So, and they are using Python. Python have been shown the last year that to be really a simple programming language that allows like even people that has no knowledge to kind of understand what the thing says in the code. So if you don't believe me, maybe you are aware of the latest Stack Overflow survey results that we had, for example, in 2018, when we saw that Python was the 7th most popular language, the 3rd most loved language, and the 1st most wanted language. Of course, this was due to all the artificial intelligence revolution that we have kind of in tech. So I was really curious to see how this thing would develop with time. So we also have the results from 2019. And to my surprise, Python is still kind of getting higher and higher in the most loved and most popular languages. So it is the truth that if you see any index out there, Python is kind of now in the top 3 of the different rankings of programming languages due to the amount of people that is currently using Python for many, many things. From microcontrollers to huge desktop applications with Qt, of course. So the key features, as I was mentioning before, is that Python is simple. I mean, if you're familiar with it, of course, you know that it's kind of almost read out pseudocode. And this is the main reason because this, if you know a little bit of history, is that Python was inspired in a programming language called ABC. And the idea of this language was the same thing that I just told you that you should read it as it was almost plain English. So that kind of enabled that Python to be a really easy to read and learn language. And of course, if you have some experience with Python, there is something that the Python community has been fighting for years now that is not really comparable with C and C++ in terms of efficiency. So this is mainly because it's an interpret language, so you cannot compile, you cannot optimize many things. So many people have been always referring to Python like maybe as a toy language or something just to learn how to code. But in the last years, we have seen many different modules that have shown us different things. So you need to keep in mind that Python is written in C. And if it's written in C, it's really easy to extend the language and start to maybe provide some new functionalities, among them maybe some really performant functions to perform, like, I don't know, number calculations or for example, some other type of like equation solutions and so on and so forth. If you're familiar with all this AI and machine learning revolution, and you are familiar with PyTorch and TensorFlow, if you have used it, it's way faster than using plain Python. And the reason of this is because most of these modules are written in C underneath. In the last years, since the beginning of NumPy, people started to consider Python as a development option because it was quite efficient compared to the old plain Python. So NumPy, for example, has many of the functions are written in Fortran and C underneath, so that's why it's so fast. And then, of course, Pandas took this concept of ND arrays and provide this really beautiful model called Pandas that you can handle large sets of data with data frames and try to filter and everything. So it is possible. Python is used in production, is behind many different projects out there. So it's something that we cannot like kind of force ourselves to believe that nobody will use Python for real. So we have many use cases, and that's why I wanted to bring most of the cute goodies to Python. So since we are talking much about Python, I wanted to put you in the context. I promised just a couple of slides regarding the Qt for Python project itself. So this project started more or less like at the end of 2007, beginning of 2008. And it was focused on Qt 4. It's a really old version of Qt, of course, since we already have 5.14. Later on, these years, the development had many ups and downs. But in 2015, there was an effort by a couple of people on GitHub to start to port Qt PySide with Qt 4 to Qt 5. So that's why they decided to change the name from PySide to PySide 2, which maybe was not optimal, but still was a solution to make a difference. In 2016, there was a really important email by Lars saying that the Qt project was really welcoming now the PySide project to be part of the Qt ecosystem. And if you have been following the development of the project, you know that in 2018, in December, Qt for Python was released. Mainly the name of the change of the name, it was due to that we had in mind that Qt for Python will not only be bindings for Qt, but many other things could be there released and exposed to the community. Among them, Shiboken. So let's take a step back and try to think like, okay, we are starting the PySide project in 2007. So which options do we have to expose this huge framework as Qt to Python, to a whole new, different language with the different paradigms and way of working? So if you're familiar with generating bindings, you are aware of Zwig, Boost Python, and also you know that you can maybe write plain C Python code to expose and generate Python modules. The first two here are really good options to get started, but since internally they kind of use a lot of templates, you know that the binary size will be really large at the end. So this was one of the main reasons of what the team decided back then, like, yeah, using Boost Python is really not an option, because if not, we will be shipping really, really large shared libraries. So I was mentioning there CPython, and I don't know if you are familiar writing C extension in Python, but I really would like for you to maybe show you how to write a simple CPython module. So let's go for a terminal. I think that everyone will be able to see this. In any case, don't worry about it. If you have some questions, you want the code or anything, you can write me afterwards and I can send it to you. So first of all, I want to start showing this simple.c file. Don't be scared about all these weird Py words there, but the most important part is that we will have a function that has a message and we return this message. So the structure for creating Python modules, besides of course including the header there, is to define the methods of the function of the module, initialization of the model, and then finally the creation of it. Here you can see all the functions that we are enabled here, only the hello function, which that is simple hello here, and it will be called hello in the Python world. Here we are defining some information about the module itself. Here, of course, you have like more options to add, like documentation and whatsoever. And this is the magical part that kind of creates the Python module. Okay, so if you're familiar with C or C++, this code should not look so alien to you. I mean, you can recognize some patterns here. So what do we do with this simple.c file? To generate modules, you can also use Python itself. So here I am showing you using these utils that you can create a simple setup call, and you can say, okay, this is the module called simple, and it will use the simple.c. So I have a little makefile here just to highlight how do you build things, and it's just writing the setup and then install. So let's write this command. So everything is compiled and everything. So here we have a little script which only does import simple and then print simple.hello. So in this case, you can see here that we get the results from our C function. So it's quite easy, right? So now we need to put this in perspective that, yeah, it's easy and everything, but are we really willing to do by hand, exposing every single class and method from Qt? I think that was not a good idea. That's why usually large projects rely on big binding generator. So this is a summary that it took me some time to create. Hopefully it can be useful for you. These are the many options that I have been personally trying to generate some bindings around, just to understand how that works. You have see, for example, here that the boost and swig are still an option because they are still in development. Shiboken, of course, here you have the other set of Qt bindings for Python called PyQt, provide a different one that is called zip. And there are then a couple of other really new and fancy modules called, like, for example, PyBind 11 is really nice, CFFI, CPPYY. Then, of course, it's up to you to see which one do you want to try. And you have here, for example, the licenses of this. So depending of how you are developing your project, maybe one option would suit better for you or not. But in any case, I encourage you to go try any one that you want here and maybe create yourself an opinion. But of course, since I have most of experience working with Shiboken, I recommend Shiboken because, of course, we have a special relationship. So how does this picture how do we do it to generate the PySci2 bindings of the Qt for Python project? So I like this diagram because it's really summarized what we do in a nutshell, and it's really easy to follow. So in layman terms, what we do is like, we have the Qt headers from the framework in general, and we use it internally libclang through our small application called API structure. So we get all the information from Qt regarding the headers. So which classes, which methods, and the signatures are, of course, really important. And also we use something that is called type system. In a nutshell, this is just a pure XML file that we can declare some stuff on it. Sometimes you need to define if a new object will live in Python or C++, or maybe you want to rename or change the type of a Qt C++ variable into something similar for Python. For example, qvariant from Qt does not exist in PySci2 because every single case of qvariant kind of exists in Python. You can have dictionaries, you can have sets, and so on and so forth. So what Shiboken does is to create and generate automatically something really similar to what you saw before in this little C file. So then we are able to have all these wrapper files that we can compile and generate a PySci2 module. If you're curious about Shiboken and you still haven't checked the documentation page, you can go to this link and see more or less all the options possible for the type system and general considerations for using Shiboken. At the moment, we are working on improvements for the documentation, as maybe you saw that the Qt for Python documentation also got some new front page. We are trying to replicate this for Shiboken 2 because, of course, we have many people using it out there. So we need to provide something that has a better structure for guiding new users and experienced users to achieve exposed in any project to Python. So what do we need to start using Shiboken? Of course, we will need some C++ library that we want to expose to Python. This could be using Qt or not. It's totally up to you. We need a list of headers, and in this case, you can see that it will be literally just the list of headers, like include some project header A, B, whatever. Then the type system specification that I already mentioned to you. You have the name of the package, and also you have there maybe some specific cases for C++ classes that you believe that should be an object or maybe a type, a value type. Later on, we have a build system. I highly recommend CMake because, of course, it's what Qt 6 is bringing to the table. So it will be really cool if you can start to get used to it if you haven't. We also provide, at least in the examples that we have in the repository, a profile if you want to use QMake. And if you are brave enough, you can maybe write your own makefile, but I don't recommend this because it would be really complicated to follow. So what I am using here locally as a development setup, it's Python 3.8.1. And we recommend Python 3.5 onwards, even though we still have Python support for Python 2 because of some user and customers. We still don't recommend to use Python 2 since maybe you heard that it's already deprecated and we'll receive the last update now in April. And every time that I want to start something with Python, I have a virtual environment. I also recommend this and encourage my peers to do so because then you are not messing up the system, libraries of Python or any other kind of like environment that you are on. So it's always good to create a virtual environment and have everything there. I am using Qt 5.14.0 from the installer, the same thing with Qt Python. So this means that I'm cloning the PySite setup repository and going to the 5.14 branch. Also, I am using libclang 8. I know that some distribution doesn't have the 8 already, but you can get pre-built packages from the download Qt.io, so you can check that thing out. And also CMake, which is recommended to use 3.1 onwards version. I am using 3.15. Don't worry about memorizing this, of course. On the link there at the bottom, you can check it out and see most of the other requirements for Windows and for macOS. Locally, I'm running Linux here, so that's why I'm highlighting these aspects. So this colorful slide is just to make you aware that when you do pip install PySite 2, automatically you get installed Shiboken 2. What you get there is not the generator. It's not what generate bindings. It's just an util module that we have called Shiboken 2 that you can use from Python for accessing different features. Among them, for example, a Python representation of a void star from C++, just to put one example there. So we have 3 wheels. When you do pip install, only you install 2 of them. So you are not able to install Shiboken 2 generator. The reason that we are not shipping this is that because a Python wheel is nothing else like a zip file. So when we unzip, we don't know where your Qt libraries and the Qt binary path are located because not all the users have this information the system-wide. So all the linking of the shared libraries and the binaries that we provide there will be not found. So that's why you will need to do some manual intervention that as we will see later on. So again, I mean, if you want more information on this matter, you can go to the wiki and see the frequently asked questions there, and there is more like a paragraph explaining this. Okay, so if you want to get started with Shiboken, you have 2 options to set up everything. The simple way and the hard way. So the simple way is similar of what you saw in the previous slide. You do a pip install, but not from PyP, the official package website from Python, but you use our own repositories. We have there in download Qt.io official releases Qt for Python. We have there located the latest releases that we have for the 3 wheels that we mentioned before, Shiboken 2, PySite 2, and Shiboken 2 generator. So once you install this thing, which is just downloading and installing in your virtual environment, you still need to do some things by hand. You need to set up the Clang install directory. So for the binaries to know where Clang is installed, as I told you, we use this API structure to get the information from libraries. You will need to have the Qt version, which matches the BiSide version that you just installed, the binary on the path, and the same with the LD library path where the libraries from Qt lives on. So I personally find myself this option really hacky. I mean, of course, also it's different for Windows developers, but I really don't like this approach. I know that some people use it and it's totally doable, but I prefer to build everything by myself. And this is the hard way. So for the hardware, you still need to point where do you have your Clang installed, if it's not in the system, of course, because if you're already on the system and you have a modern Clang version, it's totally fine. And then you just run up setup.py install inside a BiSide setup repository. This is just showing one option of this process, which is selecting where the QMake is, but there are many other options out there. You can build, for example, just the core GUI and widgets modules. You can use, of course, many cores to do the build. You can skip examples and so on and so forth. So there are many options out there. Again, if you need more information, please check .qt.io/qt4python. So let's jump into the examples. The first one that I wanted to show you is a simple hello world. And in this case, we'll have a C++ function that we want to expose to Python via Shiboken. So let's go back to a terminal. We have here the other examples. Sorry. As I told you before, the ingredients that we have is we need the C++ libraries. In this case, we have test. We need the headers, which is here, bindings. I can show it to you. So it's just included, the library header because there are another binding. And also we need the type system that in this case is called bindings.xml. And it says, okay, we are creating a project called simple. And this will use one primitive type, which is the standard string. And the only function that we want to expose is one that is called hello. If you look at the implementation of this test library, it's nothing outside this world. It's just a simple function hello that prints some message. And of course, the header also is just the declaration of this function. So once we build everything, in this case, as you can see, of course, I'm using CMake. The process that I'm using is also really simple. So CMake build, and then you do make, and then you copy the share library on. This will generate this share library option. So now, if we have the same file that we showed before, we also will be able to execute this because we generated the Python module using Shiboken. So here I want to stop a little bit and talk about the build system. I told you that it was CMake, that it's kind of easy to use. But the problem at the moment is that it's kind of verbose, and there are many options that you can set to CMake. So I am here even reusing the next example CMake because it worked and it just changed a couple of names. I just want to show you what is inside. Please don't be scared. This is really verbose because there are many comments here to teach you what the things that you need to do. For example, declaring the project, which is the standard for the C++ compiler, the libraries that you will generating, the location of the header file that we saw, and also the type system, and which wrappers we want to generate. So in this case, it's only the simple module wrapper. There are many things here that are not really maybe necessary in your project, but in any case, this is really well documented, and I really encourage you to read these things. I know there are many lines, but this is really straightforward to follow. Here, for example, you can see we have some external tool that we use here, and the reason that we do that is just to get all the proper include and leave paths into the compilation process. Then we're just, printing some nice error messages. And then we have a lot of boilerplate code just to do the installation. After here, we are generating everything with Shiboken. So I recommend you to look at this. This, I promise, is not longer than this one. This is even a temporary step just to do the install part. But as I said, and most of these things is verbose because most of the API from CMake is really verbose. As you can see, all like many words around, but it's not so complicated to understand. And in any case, of course, I recommend you to get used to it because, of course, in Qt 6, you will have to use CMake files, and it's better if you kind of start learning a few things to be able to easily pass from the profile from QMake to CMake. Okay, we had the hello world done, and now let's go to a little bit more complicated example. In this case, we will have a C++ library that, again, has no Qt in it. So we will try to expose this thing to maybe do some interaction. At the end of these presentations, I will share some blog post links, and there is one of them that described this example there, the sample binding. And just to give you an overview, what this example does is that we rely on a C++ library that has two main classes, a truck and ice cream. So as you may be guessing, we are creating many ice creams and trying to put it inside a truck, and then we do some randomization to see if the truck is kind of being able to deliver all the ice cream to many people that is around. So it's a really simple example that I really encourage you to read the blog post afterwards, because it really teach a lot of things at how to use Shiboken in this case. So let's go to it. This is a sample binding. Again, same structure. Let's start for the headers. There we have the ice cream and the truck. And the bindings here, it's a little bit more long, but just mainly because of those comments there. So in this case, for example, we have, in this case, we call the universe. We are using booleans and strings. And for the special class ice cream, we are using the object type because, of course, it's an object. And in the case of the truck, since we're using the value type, because in this case, it's not an object that we initialize in Python itself. So here we have a couple of specifications for functions that we want to modify, like the clone and the ice cream flavor, that we want to modify a couple of things. Index 0 here means what the function is returning. So we are saying that the returning value of the function clone will live in C++. And in this case, the first argument of this function will live also in C++. This is important because sometimes when you are creating a new object for Python, you need to specify where it. So this object is living in Python world or in the C++ that is running underneath. So if you look at the type system that we had in Qt for Python project, you can see many other use cases for different Qt classes. So with this is really critical to have a proper behavior. So if we look at, let's look first at the ice cream header. So it's a really simple C++ class. We have a constructor that receives a string, and we have a couple of virtual methods that we will need to implement in Python, like a flavor, for example, and the clone that we already saw. We have only one private variable here, which is the flavor. Let's look now at the truck. So here, again, same, a couple of others more methods that we want to use, the deliver, arrive, leave, just to see the status of everything. Nothing here should be strange to you if you have some experience with C++. So I will say that let's jump into it, how this thing will work. So once you expose the truck and ice cream classes, you can go here, for example, we can look at what the Python file will look like. And well, the first import is just to have Python 2 compatibility. So we set there that the project was called universe. And we already mentioned that we have two main classes, ice cream and truck. So as you can see here, of course, since ice cream is not a flavor, we are creating many flavors based on the ice cream class. In this case, we have vanilla chocolate, and here vanilla chocolate cherry. And as you can see, we are just specifying the get flavor and clone virtual methods. So we are implementing here in Python. The main process of this is really simple. We create a truck with some status, and then we will have some flavors that we want to start to create ice creams. And then we will add those ice cream flavors to the truck. So after we finish adding everything, we will see, okay, so the track has arrived. Let's print all the available flavors and randomize the delivery process, as you can see here. So depending on this randomized event, we will do maybe create a special track with even more flavors, and so as you can see here. But then after all, this is just mainly interaction with the class itself. So let's build this thing, CMake again. And also here, okay, everything is installed. I just wanted to show you that again, this little make file that I have here is just to show you what I am doing to build the project. And then we are able then to execute. So you can see all these things. So the new tracks arrive, he has the following flavors, and then didn't manage to get a flavor to someone. So that's why we create a new special ice cream track, and then we have all this interaction here. So of course, it's really like a toy example because it's just sending around just text, but it's not real application, right? So let's jump into this really shiny example that I personally like. It was one of the first one I tried to modify and play around with it. So it's really cool. And the good thing about it is that we already showed this example in World Summit last year, and we got a lot of attention from people. Everyone wanted to do the same thing. And at the moment, we have many customers and users also using this example as a base of larger projects. In a nutshell, what you will see now, it's a Qt C++ interface that is nothing else than a Qt main window. That inside we have a plain text edit that will be able to write some Python code on it. So you say, okay, so you are creating an IDE. Well, maybe just for this example, it's kind of similar, but the idea of this is that you are kind of shipping also the Python interpreter to your C++ application. So this means that you will be able to run Python code inside your running C++ application. So if you still cannot see a real use case of this, is that let's put an idea of like any C++ Qt application at the moment, and you want to maybe start a plugin system for it, so people can write add-ons. And maybe some of your users are not familiar with C++, so maybe you can provide a way of people to write plugins in Python. So this is really cool. And we had last year, 2 years ago, even an intern working on extending Qt Creator, the IDE that we have at Qt, to be able to write plugins in Python. And there was a proof of concept there that worked quite well. So we are maybe planning in the future to take this project out, and so you will be able to write Python plugins for Qt Creator. So let's jump into the example. This one is a little bit more complex, as you can see here. We will go through the main things that we have. So first we have the wrap classes. Sorry for the license there, but the most important part here is that we are using only the main window.h that we have locally, as you can see here. And the main window.h, it's nothing else that simple Q main window class where we have some plain text edit. So this function will have this class will have some functions here. I put some getters for the plain text edit and also the toolbar to speed up a few things. We have the option to run the script too, and a couple of slots because of course we have some interaction inside the application. So I want to stop here in the run script method. So these methods lives in another set of Python files, C++ files that you can see here. So what do we have here in the Python utils is all the interaction and connection with Shiboken. So in this case, for example, we have here the Python utils namespace when we have some application library type, the state of the application, and the most important function here, which is the function that binds a specific application object from C++ to Python. So if you go there to the implementation of this file, we can see here we are using the Shiboken headers. we are setting up something regarding the application. Just for this follow the same structure of the first code that I show you to create a simple CPython module. We have some types from all the Python types that we already have in the Shiboken, the same with the converters. So we don't need to rewrite everything. And then we have here the initialization of the model itself. Of course, if we are working on a virtual environment, we need to set up the Python home, the variable, because we need to know where the libraries and the executable are. Then we initialize this, and the most important part I was mentioning before, that we have a function here that enables us to expose a specific object that lives in Python, that lives in C++ to Python. So we have this interoperability, and we have a connection both sides. So we can do things from Python and interact with C++ objects and the other way around. So this, we are importing here modules. The module name here could be maybe PySide2 widgets or something else. And then we are calling this just to import something in the internal Python interpreter that we have. And last but not least, we have here, how do we really run the scripts? Since we are using Python.h, the API provides us a nice method that is called PyRun simple string. So what we are doing is just to grab everything in this queue, plain text edit, and stream it in the simple string run so we can get the execution of this. And if there are some errors, we can kind of get something. Okay, so let me show you this example. This is already, even though the make file is here, the build process is the same that we already saw. I already have compiled here just to save some time. I would like to keep here the application open, and you can see on the left, there is this white block here that you can see there. And the main problem here is that maybe you cannot read what is there, right? So don't worry about it. So we will do say style sheet, font size, let's do 20 pixel, boop, run. So what I just did was writing a line of Python code that was modifying the whole font size of the application, because we have this connection between the application, between Python and C++. Also, since you see this function here, you can see a status here that said was calling 1, and then if I run again, twice, 3 times, because there is a static counter there that is kind of taking care of this. So you have other options here to run, to show the about queue, some menu that we add, of course. And one of the things that we have here, for example, let me just copy here, we can clear this and paste again these things. So now we don't have any output and we don't have any status. So let's do something. So let's imagine that we are writing a plugin for this. It's kind of really limited to IDE, but I guess that you get the idea that at least you can write. So let's try to do something cool. So as you can see, this is kind of highlighted in my desktop because everything else is kind of using the dark mode. So let's write, for example, a plugin for this application to have dark mode there. So since it's not an IDE or my Vim editor, maybe I will make mistakes, but I guess that you will spot them and maybe understand them the error. So first, okay, let's go and try to import from widgets the Q action. And let's do this from something really simple. So we create a global variable, is dark mode false, and we will, even though this is not a good practice, it's just for getting the example done. So, okay, we first would like to have something here. So we have some method that I briefly showed that it was called get toolbar. So, okay, let's create something, get toolbar, main window, get toolbar. Okay, so we know that we will have the access to the toolbar itself. So since we imported action, let's create another action and let's put it, I don't know, dark mode. So we have this action. So if you have some experience with toolbars, you know that you have the add action and then you can have the action there. And we will need to do something about it. So we can create, okay, maybe we can create a local module in this case. Okay, so let's trigger to connect and let's call something like change mode. And let's create the change mode here. change mode, and this is really 1, 2, 3, 4. This is really not a good practice, but it's just to get things done. I will move a little bit to the right. So here, okay. So we have this access to this global variable. So let's say like if is dark mode, we will do something. But okay. But first, if we want to modify this thing, maybe we need to kind of have access to the text edit, right? Because also we will need to kind of modify what is happening here because it's white. For this, also there was this function that I showed before. It's called get text edit. This will give us the access to this edit in any case. So if 1, 2, 3, 4, if we have here, so let's change, for example, the main window, set style sheet, and we will use the background color. I really like the one that how much is E88, E7, I think. Color white. No, in this case black, because of course this is to disable the dark mode. And also here we will do to the text edit, we will also set some style sheet and background color, and here let's just use white because this is the light time, and we need to of course change this thing that is not anymore. In the case of the else, I'm really lazy here, so I will just copy and paste this. In this case, of course, we need to change main window set style sheet, the background color. I think that's the one that I used before was 31, 36, 3B. And in this case, of course, we would like to have maybe fonts that are white. Oh, this is wrong there. And here, let's put maybe gray background. And in this case, we have, it's currently a dark mode. So, okay, let's me review quickly this. Okay, we have widgets, we import Q action, then we have this variable change mode, we have the global get main window get text edit, dark mode. So with main window we cell style sheet, the background color, black, yes, then not missing any quote or anything. The same with the background, we have the global variable there. I think that's everything looks correct, but in any case, we can check, and if it doesn't work, we start over. Okay, so first I will run this thing. Whoop. Oh, and there you have it. At least we have the new action created there. Okay then, so what I would like to do now is like, I don't know if I should. Okay, let's click the button. Boom. Okay, so this is now dark mode, and if we click it again, we have the light mode. The font is not being, in this case, executed, but you can add it here, like font size 30 pixels, and the same here, font size 30 pixels. Let's run it. Okay, yeah, in any case. So now we have, as you see, I really want to have some time for questions. So the main idea, at least I think that is clear. We have the dark mode there, enable and disable. So it was not so difficult. So this is a really kind of like a really kind of good place to maybe start adding the possibility to add scripts to your application. I think that if we run this again, we have a second run dark mode. Oh no, we still have it. Okay, good. So there we have it, the font. So you see the change worked. So yeah, I hope that this was kind of okay for you to kind of like understand the idea of this example and the amount of things that you can start doing with your own applications. Okay, let's close this now. Let's go back to the presentation. So I was mentioning before the resources. If you haven't checked the blog, there is a blog post that I wrote about the technical vision of Qt for Python for the Qt 6 offering. I recommend you to go there and read it. Regarding Shiboken, we had a couple of blog posts too in the past The first one is an overview on the how Shiboken works. The second one is the ice cream and truck example that I mentioned and we executed. And this one, the last one, the Python extension one, is the one that extend Qt Creator with Python plugins. And also, we were really lucky that one of the members of the professional service in Boston visited us and last year here in Berlin for the World Summit and gave a really good talk of a real use case of Shiboken. So if you're familiar with the QWT module, Sharon managed to expose QWT to Python using Shiboken. So I recommend you to go here in resources.qt.io and just look for Shiboken, and I think that is the only talk that we have there. And it's really enlightening and it's really well explained. So besides this, what I can tell you is that at the moment we are actively developing Shiboken and Qt for Python, of course. So we are open to many suggestions that you may have, or of course trying to add support for new features. As I mentioned before also is that we are currently working on improving the documentation just to make the life easier, everyone. Since the Scriptable application example, the last one that we saw, it's so important and so interesting, we are planning to write a whole tutorial just around this tool. So explaining every single bit of this application so everyone will be able to understand. And of course, something else that we need, it's the tooling around Shiboken, because at the moment, this XML file, the type system, you need to write it by hand, and the same thing with the headers and everything. So hopefully we can end up with some nice tooling around Shiboken that can make our lives easier. As I said before, we are really community driven, and most of the support that we have been incorporating into Shiboken comes most of them from users that we have out there, that they are kind of asking some questions in our IRC channel. So I really recommend it for you to give it a try and just submit any suggestions or reports that if you would like to have something new in Shiboken. So I encourage you to, again, to just drop us an email, message, or whatever, just to give some ideas of how we can improve Shiboken. Here you can see a couple of things. We are really active on RSC in the Qt PySide channel on Freenode, but we understand that not everyone is an RSC, but so please check our wiki page here, pyside.org. You can see other community chat things that we have. For example, we have Telegram group, a Keybase. We also have Riot Matrix, we have Gitter, and so on and so forth. So I am pretty sure that you will use one of those that you can join maybe the channel to ask questions. This, you have the main landing page with some examples and the official documentation that I was mentioning before. And if you like mailing lists, you can subscribe to our mailing list too. If you have some particular question of the presentation and you want to ask me, here you can find me on Twitter, for example, and at Maureira. Okay, so now I see that we have some questions already, so I will jump into the questions. Let me just keep sharing my browser there. I will go now for the QA. So I see some questions here. What is roughly the deadline for the new Shiboken documentation? Well, it's hard to tell. I can tell you that at least I am personally working on this, and I have some work in progress patches locally because I want to, of course, submit something new. But just to give you an idea, we'll just to put a different order on what we currently have, because at the moment it's an index with many topics, but we don't have, you know, a kind of like a way of easily follow what getting started to kind of use Shiboken professionally with exposing some library. Okay, okay, so we have the next question is, what is the truck defined as value type with the SQL is of object type? Yeah, so as I was saying, I mean, it really depends how you have your implementation and when you want to use C++ objects, and they are passed by reference or they are just copying. So it's just a matter of having different ways of, because sometimes you don't want to copy objects every single time, so then you use the object type. On the other way around, if you want to pass something by value, then you use value type, and so on and so forth. But in any case, I mean, in the documentation, you have some examples on other things, because also there are other types. I don't remember which one was the other one. In any case, there's another type that you can use. To make a useful Python script application, editor with a debugging mode that allows stepping through the Python is something like that. Yes, I mean, I personally use Qt Creator to debug these things. I have locally Python built with debug symbols, and also I built PySide with debug symbols. So I step through easily uh, through all the, for example, the implementation that we have in Shiboken, and also what is the core of Python itself, Andrew. So if you have some questions about the setup of this, just drop me a message, and I can let you know how to proceed with this. I also have been thinking of maybe creating a video tutorial, how to start debugging real Shiboken or PySide bugs, so you can get an idea of what we are doing as developers. There is another question by Dennis. Why not making the generating grid XML files so using annotation in the headers that will be single place, blah, blah. So, okay, yeah, generating the XML, Dennis, yes, it's a really fair point. This was discussed on the Qt Contributors Summit last year too. It's mainly because at the moment, we don't have the information in Qt about, for example, ownership transfer. So what happened with maybe when you are using the add widget method and you are taking ownership of this thing. So that's why it will require at least some manual intervention of saying like, hey, you know what, this method will take ownership of the object that we are passing. So I am totally agree with you, and this is some of the tools that we want to do to at least list all the classes that we want to expose, and then at least you can manually just add this the ownership transfer or maybe some modification. And Dennis also is asking support planning for Ubuntu templates. Okay, this is a really tricky question because I really don't know a way that how we can know beforehand what will be the type of a template. So at the moment, for example, the closest approach that we have to support templates is to have a limited amount of types for some templates, and maybe kind of limit that thing, and maybe using a, I don't know, a Lambda function or something to kind of have some idea of kind of callback. I'm kind of speaking about a specific template class, which is the Qt page template, no, page request callback or something like that in Web Engine. So there could be a workaround kind of supporting templates in that way. The other option that I kind of see is to maybe play around with the implementation and maybe have modified the signature and maybe try to pass the type as the first argument on the function. But still, this is something that we have been trying to address since a long time, but we haven't done any kind of smart decision on that. So I really would appreciate, Dennis, that maybe if you have some ideas, you can share some suggestions on the Jira or send us an email on any of the platforms that we have. Mason is asking, are there plans to be able to target mobile platform with Qt for Python? Yes, there is plans, but at the moment it's mainly about prioritization. The Qt offering in mobile is kind of staying there. It's kind of you can do a couple of widgets and so on, but to start to provide interaction with Python and mobile, like Android, for example, we will need to do other type of things. Python itself has problems with mobile development in general, and the only solution out there is to kind of have transpilers that kind of maybe transform your Python code into Java code that can be running Android or Kotlin or Flutter or whatever you're using. So it's quite tricky. I mean, the same case with the JEPTC about for iOS that you will need to have some mechanism in place to kind of transform all this code to be able to be compatible with mobile device. So yeah, it is in our backlog, but at the moment it's not in between the top 5 priority things that we want to do. But in any case, again, Mason, I mean, if you have some ideas or maybe you're kind of like intrigued on how to start doing it and you want to start something by yourself, we can also give you a hand and maybe you can start playing around with it. Do you know if it is macOS App Store compatible, Artem? I don't have much experience, Artem, developing for the App Store. I think that there is some signing requiring there. I do recommend you to check maybe with the people that is working behind deployment tools. There is like a couple of tutorials that we have there on our website, and I think that you will be able to find an answer there. among the people that is deploying an application and maybe put it in the Apple Store, but at the moment I don't have an answer. Was the Scriptable window dependent on a Python install, or where the Qt lives providing all the functionality? Yes, it was depending of a shared library that we will link in while generating the Scriptable application binary. So yeah, so that's, you need to take care of this, Ken, because of course you need to know which shared library that from Python you are using in your application. And in this case, that's why, for example, we had this detection of the virtual environment, because we wanted to use the same thing where we have everything built. Okay, Artem is asking again, how strict is Qt for Python API backward compatibility? How often it will get broken? We usually try to respect what Qt is doing. At the moment, for example, we had an issue with Python 3.8, so we waited until Python, the 5.14 release to try to get all these fixes done. So, for example, you cannot use Python, Qt for Python 5.12 with the Python 3.8, for example. We are planning to do some backport and cherry picking there, but so far, we haven't changed API at all. The only thing that might change in the future is that we have a QApp singleton to kind of get the insights of different Qt applications. And that will be it. I think that everything else will be, I think, compatible. And I think that, yeah, we will kind of try to respect the backward compatibility that Qt has. But of course, for Qt 6, we will break the API as Qt is breaking it already with all the plans. So at least in Python, in Qt for Python 5.12, 13, 14, and 15, I'm almost certain that it will be almost 100% API compatible. Okay, so we don't have more answers at the moment. I think that you will still be able to see the slides. So in any case, if you still have some questions, maybe something was not clear, just drop us a message there, and you have there my Twitter account. So if you want to, I don't know, send me a message or something, feel free to do so. And yeah, I'm really looking forward to see you playing around with Shiboken and let us know what you think. So that would be from my side, Iris. So.
Thank you for this, Christian, and thank you everyone so much for joining our live webinar today and asking all of your questions. We will be ending the webinar, and if you have any questions for your projects, we are more than happy to answer them for you in the on our website at qt.io/contact-us, and we look forward to connecting with you soon. Thank you so much.